Hey guys, welcome back to the Sleepy Scholar. Tonight I want you to imagine a place where the sky whispers through leaves and every drop of rain carries a memory. A place where trees breathe slowly and the soil remembers stories older than time. You're not just going to learn about the Amazon rainforest, you're going to feel it breathing around you, guiding you gently towards sleep. So close your eyes, let your breath slow down, and allow the forest to carry you leaf by leaf, root by root, into a dream where everything is alive, but nothing is in a hurry. Let's begin. The forest does not rise all at once. It climbs in layers, slowly, like a breath drawn in stages. At your feet, ferns nestle in soft loam, delicate and low, drinking the darkness without complaint. Above them, shrubs stretch their arms just a little further, catching slivers of stray light that pierce through gaps in the ceiling above. Then come the understory trees, patient, narrow beings who wait years, sometimes centuries, for a break in the canopy. And finally, towering above them all, the giants, the emergents, and the lords of the canopy, whose crowns shimmer in full sunlight like ships in a golden sea. This is the ladder of leaves, and your body is already climbing it. As you begin this journey upward, the air changes with every few feet. It thickens with scent of bark and lichen, of slow-moving sap and unseen blooms. Your breath slows. Even your heartbeat feels quieter here. On the lower rungs, life presses close. Insects hum near your ear, vines loop like question marks, frogs blink from hidden crevices. You pass bromeliads cupping tiny pools of rainwater, miniature worlds with their own skies and swimmers. Every leaf seems to carry its own secret, written in veins and chlorophyll. The first true lift comes from the lianas, thick, woody vines that twist like memory, rooted in the forest floor but reaching with purpose toward the light above. These are not parasites, but passengers, using the bones of the forest to ascend. You feel their ambition as you step or swing past their muscular coils. Monkeys use them as bridges, snakes as shade, even orchids find footholds in their curves. Every inch of vertical space is spoken for, but never in competition alone. The ladder of the rainforest is built on cooperation as much as it is on rivalry. Halfway up, you enter the dim cathedral of the understory. The trunks here are thinner, but not young. These trees have been waiting for decades, absorbing what little light seeps down in mottled patterns. Their leaves are broader, designed to catch even a whisper of sun. You run your fingers across one, leathery, cool, a little wet with the breath of the forest. It does not tremble. It simply exists, in patience, in presence. Here photosynthesis is not a rush, but a slow communion between light and green. Now the ladder begins to wobble. The higher you climb, the more delicate things become. Branches grow thinner, bark peels in ribbons, lichen paints the trunks like ancient scripts. Small birds flit past you, hummingbirds, tanagers, antrons, each claiming a patch of space, a song, a beat of air. You hear wings more than you see them, a pulse of feathers, then gone, and still you rise. Near the top, the light breaks open. You emerge into the canopy, and the change is like waking from sleep. Suddenly your skin warms. The soundscape transforms, louder, fuller, layered with calls that only carry in open air. Cicadas drone like electric violin strings. Macaws screech with primal color. Somewhere, high above, an eagle pierces the clouds in silence. The trees here sway with their own weight, massive and slow. Their branches form highways, not just for animals but for air, for pollen, for spores. The wind becomes storyteller here. You sit, you breathe. Your chest lifts and falls like the leaves around you. The sun dapples your skin through a million green filters, and each breath tastes faintly of life in process. Warm, bitter, bright. You notice things your eyes might miss in daylight. The way moss clings to the undersides of branches, the shimmer of a spider's web catching moisture, the quiet creak of a tree adjusting its weight after decades. Everything here moves, but nothing rushes. And then it comes, that single moment of stillness, when you no longer feel like a visitor. You are part of this vertical system now. Your body has aligned with the ladder's rhythm. The ground is memory. The sky is not yet goal. You are suspended, not just physically, but emotionally, in the middle of something vast and alive. A sloth blinks slowly from a branch no thicker than your wrist. It knows the ladder by heart. It doesn't need to climb it, it simply is it. You watch it reach for a leaf, its motion like a sigh. There is no urgency here. Even survival obeys a slower clock. You find comfort in that. Somewhere nearby, a leaf detaches. It falls silently, spiraling down through all the layers, from sunlight to shadow to soil. One step in the forest's ongoing breath. You wonder what it will feel. You wonder how many others fell while you climbed. As the light softens, the canopy begins to change. Day creatures grow quieter. A new rhythm prepares to rise from the floor. You remain still and breath-wrapped on your perch in the leaves. The ladder stretches above and below, but for now, you rest in between. Sunlight in the rainforest is not generous. It is rare, filtered, precious. What reaches the forest floor is a softened echo, a memory of the sun that once touched the treetops. Only 2% of sunlight reaches down there, yet the entire forest is built around this scarcity. Every plant, every leaf, every angle of every branch is shaped by a silent geometry of light. This is not just a forest, it is a living equation of energy, constantly solving for survival. As your breath slows, you begin to feel how sunlight doesn't just fall. It flows, trickles, bends. Like golden water, it drips through openings in the canopy and spills onto leaves like secrets. Where light lands, life blooms. Where it doesn't, life waits. That is the rhythm here. A single beam of light can become a battleground, a miracle, or a message, depending on where it lands and who claims it. You notice the shape of leaves change as you descend through layers. In the canopy, they are smaller, tougher, thick-skinned, built for constant exposure. Below, leaves become wider, thinner, hungrier. Some even shift position throughout the day, tracking the light like slow dancers. This movement is not random. It's called heliotropism, a choreography of hunger. Each plant turns toward the sun, not in desperation, but in reverence. Understory plants live in permanent twilight. Their leaves are so wide they resemble green hands, open to the sky, begging for what little light may fall. They contain more chlorophyll, the molecule that turns sunlight into sugar, making them more efficient. Some plants, like the giant philodendrons, develop a strategy of patience. They wait until a nearby tree falls, an event called a gap. Suddenly, sunlight floods a forgotten part of the forest, and the waiting plants explode into growth. It's not luck, it's evolution poised like a breath held too long. Even animals live according to this hidden sun. Butterflies gather in patches of light, not just for warmth, but to charge their muscles for flight. Birds choose singing spots, based on the angle of morning beams. Lizards flatten their bellies against sunlit bark, absorbing energy through skin. Every life form in this forest, even the ones that do not photosynthesize, lives in devotion to light. Sunlight also dictates time. In the rainforest, there are no seasons in the way temperate forests know them. Instead, the rhythm is light and rain, day and dusk. Each tree knows the length of a day. Some flowers bloom only in the late afternoon, when the sun hangs low and sweet. Others open before dawn, trusting moths and bats to pollinate them in darkness. These aren't random timings. They are ancient contracts, written in light. And light speaks in color. You see red flashes, heliconias, bromelias, ripe fruit. Bright hues attract birds, insects, even monkeys. But there's danger too. Some red warns of poison, like the skin of a dart frog or the belly of a venomous caterpillar. Light reveals, light deceives. It is both invitation and warning. Deep in the forest, there's a plant called the solanum, whose leaves are nearly black, an adaptation that allows it to absorb even the faintest light. Another, the macrolobium, uses reflective undersides to bounce spare sunlight back up to itself. Some plants give up entirely and become parasites, like the mistletoe, which steals sunlight indirectly through a host. In this ecosystem, light is not a gift, it is a resource fought for with beauty, strategy, and silence. As you recline against the trunk of a giant kapok tree, you feel dappled light warm your shoulder. A single beam touches a nearby sapling, illuminating it like a spotlight in a green theater. That sapling, no taller than your knee, may one day become a 200-foot colossus, if the light keeps visiting, and the forest allows it time. You realize that every great tree here was once a shadow watcher, a dreamer in the dark. Above you, a leaf shifts slightly in the wind, and the light moves with it. It sweeps across the moss, over a spider's web, and then vanishes, gone. As if it was never there, and in that moment, you understand that light doesn't just shape plants. It shapes moments, moods, memories. It carves time into golden fragments. You close your eyes, and behind your lids, you still see the shapes of leaves in sunlight. Not sharp, not solid, just flickers and fragments, the way the forest dreams of the sun. In the rainforest, space is not measured in distance, it is measured in direction. Not how far you go, but how high you rise. Every trunk is a climb. Every branch is a foothold, and every inch upward is a victory won in silence. The fight for space in the Amazon is not loud. It happens leaf by leaf, cell by cell, in slow green ambition. Trees are born in shadow, but they grow toward light, like longing takes root in the chest, upward, steady, unstoppable. From the moment a seed falls to the floor, it enters a race it cannot see. The forest is already crowded, trunks packed like cathedral columns, vines tangled in tight choreography, mosses thick as blankets. But above, there is light, warmth, air, and the only way to reach it is to climb. Some plants shoot upward with determination, growing straight and tall, in as little time as possible. Others, like strangler figs, take a different path. They wrap around their host, embrace it gently at first, then tighten with time. It is not cruelty, it is efficiency. In the Amazon, survival is often beautiful and ruthless in the same breath. The canopy is a living ceiling, but it is also a battlefield. Trees extend their crowns like shields, overlapping, interlocking, blocking light from competitors below. A single branch from a neighboring tree can change another's fate by stealing just enough light to halt its growth. Some trees, like the cecropia, grow fast and lean, piercing through gaps quickly. Others, like Dipteryx or Bertholitia, the Brazil nut, grow slow and thick, relying on sturdiness and age to win their place in the sun. There is no one right way, only what works. Even epiphytes, plants that grow on other plants, have entered this upward fight. They do not root in soil but perch on branches, using trees as scaffold. Bromeliads, orchids, mosses, and ferns turn limbs into gardens. They take nothing from the host, only light and rain. Still, their weight can break a limb over time. In a forest of balance, even support has consequences. Animals, too, are part of this vertical contest. Sloths live in the middle layers, moving slowly so as not to attract predators from above or below. Monkeys chase fruit at the top, while snakes wind their way up from the bottom, silent as vines. Birds fly not just to move but to claim their level. Hummingbirds in the understory, toucans in the mid-canopy, macaws in the open sky. Every level of the forest is a neighborhood, a territory, a home earned by adaptation. Storms test the architecture of ambition. A tree that grows too fast, too thin, may break in the wind. A liana that climbs too quickly might lose its anchor, but a well-rooted tree, with deep taproots and wide buttresses, can sway without snapping. The rain doesn't punish, it proves. Trees that fall open patches of light, and the cycle begins again. New seedlings race toward the gap, fueled by the sudden absence above. In this vertical, decay and rebirth are part of the same strategy. Fallen logs become nurseries. Dead trees are not wasted space. They are scaffolds for moss, fungi, beetles, and fern. The fight for space does not end in death. It continues, transformed, passed on. Even rot has direction here. And then there are the emergents, the few trees that break above the canopy itself, rising 200 feet or more into pure sky. Their crowns are solitary, their leaves tremble in wind, no other leaf below can feel. To become one of these is rare, slow, and sacred. These giants, the capacock, the Brazil nut, the mahogany, do not just grow, they ascend, they remember. You sit at the top of one now, in a fork between branches, feeling the sway beneath you. The sky is not above, it is around. Blue light stretches endlessly, clouds drift like slow animals, birds wheel in spiral arcs, and beneath you, the entire forest exhales, layered, green, breathing together. You realize then the fight for space is not just about winning light, it is about becoming part of something taller than yourself. You look down, and what once felt towering now feels fragile. What once felt vast now feels intricate. You understand that everything in this forest reaches for something: light, water, warmth, place, and yet nothing climbs alone. A single leaf, golden with evening, detaches near you and floats downward. You follow it with your eyes until it vanishes into green. Somewhere down there, another seed begins to stir, touched by its foot. The ladder resets, the sky remains. You walk through the forest, but the real pathways are not under your feet. They are beneath them. Hidden in the soil, silent and vast, is a network older than trees, older than the forest, older than memory. A living web of fungal threads called mycelium stretches beneath the roots, invisible but alive, connecting every tree, every shrub, every blade of green in an underground internet of life. It is not merely a structure, it is a whispering intelligence that binds the forest together, wordless but wise. Mycelium is made of hyphae, microscopic strands that braid through soil like threads of breath. From a single spore, it branches outward endlessly, mapping the world in silence. These threads wrap gently around roots, not invading but merging, forming mycorrhizal partnerships, where trees offer sugars created by photosynthesis, and in return, the fungi bring water, minerals, and ancient knowledge. This is not charity. This is trade, mutual, essential, sacred. As you stand still, feeling the earth beneath you, it's strange to realize that a tree is never truly alone. Its roots may stop at a few meters, but its influence spreads through the fungal web far beyond. One tree may be connected to another dozens of meters away. A sapling, still struggling in the shade, may receive nutrients from a mature tree it's never touched simply because the mycelium relays the need. Scientists have called this the wood wide web, but the forest knew its name long before we did. In the damp, dark underworld of the rainforest, this network pulses with communication. A tree under attack from insects may release chemical signals through its roots. Mycelium carries the message to neighbors, who begin producing defensive compounds before the threat even reaches them. It is as if the forest prepares, not with panic, but with practiced wisdom, a system of alerts without alarms. But this is not a world of endless harmony. Mycelium also chooses. It can favor certain trees over others. It remembers. It rewards those who give back more, and punishes those who hoard. A selfish tree may find itself isolated, its fungal lifeline withdrawn. In the soil, community is earned, not assumed. There are two types of mycorrhizal fungi in the Amazon: arbuscular mycorrhizae, which penetrate the roots of tropical plants, like the inside of a handshake, and ectomycorrhizae, which coat roots in a soft glove. Each type serves different species. The forest does not run on one system, but many layered, adapted, diverse, and within this diversity lies its resilience. Fungi do more than connect trees, they decompose the fallen, digesting dead wood leaves and creatures too small to name. In doing so, they recycle nutrients, returning life to the soil. A fallen tree becomes a feast, a dead animal becomes breath for a vine. Decay here is not the end, it is translation. Mycelium reads the language of death and rewrites it into growth. Even the smell of the forest, that rich, damp, ancient scent, is shaped by fungi. As they digest, they release geosmin and other earthy compounds that drift upward. You breathe it in and unknowingly inhale the memory of decomposition, the breath of the underground. Sometimes when the forest is still, you might notice tiny mushrooms pushing through the leaf litter. They are not the fungi, only the fruit. The real body remains hidden, spread across meters or even hectares beneath. These mushrooms are the forest's punctuation marks, brief, bright signs of something much larger, much quieter, and somewhere in the dark, where sunlight will never reach, mycelium continues its work. It spreads, it senses, it waits. Some threads may sleep for years, waking only when roots or rain arrive. Others grow toward chemical signals, bending and twisting like fingers feeling in the dark. There is intelligence here, though not in the way we understand it. No eyes, no brain, just awareness, slow, distributed, and ancient. You kneel, place your hand on the soil, and try to imagine it, miles of living threads just beneath your palm. Threads that connect past to present, death to life, tree to tree. Even you, if only you stayed still long enough. The forest is not just above, it is also below, deep and wise and alive. And in this quiet depth, where no leaves rustle and no birds sing, the real forest breathes, slowly, invisibly, beneath your feet. Beneath the thick skin of the forest floor lies a hidden nervous system, one made not of neurons but of roots, reaching, branching, listening. Trees in the Amazon do not grow in isolation. They grow together, their roots weaving through soil like sentences in a shared language. Each tree speaks in sugars, signals, moisture, and memory. What begins as a search for water becomes a dialogue, silent but deep, among all who dwell in the green. Roots stretch outward like quiet explorers, sensing changes in pressure, chemistry, and touch. When one root meets another, even from a different species, there is recognition. They may avoid each other, compete gently, or share space. But when connected by mycorrhizal fungi, something else happens: cooperation. Roots begin to speak through the fungal threads, sending signals, warning of drought, calling for support, or simply exchanging nutrients. The forest at its root is a conversation. Studies have shown that when one tree suffers, say from drought or insect attack, its neighbors respond. Even trees that are not yet touched begin to change. They close their pores to conserve water. They produce bitter compounds to deter future grazers. Somehow they know, this is not magic. It is chemistry, relayed across a living network of roots and fungi. It is the wisdom of community, practiced in silence. Young saplings, especially those born in deep shade, rely on this network more than anything else. Their leaves may not catch enough light, but their roots can still connect. Elder trees, often the mothers of the forest, pass down sugars and water to these shadowed children, sustaining them until a canopy gap allows their growth. It's a kind of slow parenting, not seen but deeply felt. And the mycelium acts like the forest's midwife, nurturing, balancing, remembering. Not all communication is soft. Trees can compete too. Some release chemical signals, allopathic compounds, that inhibit the growth of nearby plants. This is not cruelty, but boundary setting, ensuring survival where resources are scarce. Yet even in competition, there is order. The rainforest rarely wastes. Every molecule has purpose, every interaction a weight in the scale of balance. Roots also play messenger between species. A vine climbing a tree may not touch the soil at all, yet its fate could be determined by the tree's decisions below ground. If the host tree is well connected, the vine flourishes; if not, it withers. Even epiphytes perched in the canopy depend on what flows through the trunk from the roots. Nutrients gathered meters below feed flowers blooming high above. It's a vertical highway of nourishment. And roots are sensitive. They respond to sound. Experiments suggest that roots can detect vibrations, footsteps, rain, even the movement of worms. This sensitivity allows them to grow toward what they need, and away from what they don't. A root can bend slightly to avoid a rock, seek moisture, or stretch toward a neighbor. There is choice in this motion, not thought as we know it, but something like awareness. If you could see it all from below, from within the earth, the forest would look like lace, a web of roots, thick and fine, tangled and patient, pulsing with water and signal. And through this web, the forest keeps time. It remembers past floods, anticipates droughts, senses the lean of a tree long before it falls. The memory is not in the leaves, but in the ground, in the living roots that store experience. You sit quietly, palms resting on the soil, and wonder how long it takes for a tree to speak. Not in seconds or minutes, but in seasons. In the dry months perhaps one sends a signal, in the wet another responds. The rhythm of this language is measured in rain, in roots, in reaching, and you too begin to feel it, the hum beneath you, not in sound but in stillness. A slow vibration of life, communicating not to be heard, but to be understood. You close your eyes, and in the hush, you realize this forest is not quiet. It is full of conversation, ancient, slow, and always ongoing. Soil is not a background, it is a record, a living memory kept not in words or symbols, but in layers, textures, and chemistry. Each handful of Amazonian earth holds more than just minerals. It holds stories of rainfalls long past, of roots that came and went, of creatures that lived and vanished. The soil here is not simply dirt, it is the forest's diary, written in the language of time. You kneel and touch the ground. It is soft, warm, slightly damp, a mixture of fallen leaves, broken twigs, forgotten fruits, and life too small to see. 1,000 invisible mouths are feeding in this very moment. Bacteria, nematodes, fungi, protozoa, working not alone, but in cycles, each feeding the next. This ecosystem is microscopic, yet essential. What falls from the trees becomes part of the soil, and what the soil gives rises back again, as roots, stems, and breath. Beneath the surface, organic matter decomposes, but not into nothingness. It transforms, breaking down into carbon compounds, nitrogen forms, phosphate patterns, each one used again and again. The forest builds itself from its own ruins. This is not decay, but alchemy. A fallen leaf may become part of a vine. A dead insect may feed a tree. Even the bones of small animals dissolve into nutrients that one day blossom as flowers. The forest never forgets what it loses. It simply reshapes it. In certain patches of the Amazon, you might find something different. A dark, fertile layer called terra preta, or black earth. This soil is not natural. It was made by ancient hands, indigenous communities, who enriched the land with charcoal, bone, compost, and clay shards. Centuries later, it remains astonishingly fertile, still growing crops where surrounding lands struggle. This too is memory, a human echo written into the land, evidence of sustainable wisdom far older than modern science. Soil responds to rhythm. It changes with the rains, softening into mud, then firming as the water recedes. It drinks deeply, stores moisture, and releases it back to the roots slowly, like a careful guardian. During drought, certain bacteria awaken from dormancy, aiding in resilience. After fire, some fungi only fruit in the ash. Even destruction becomes part of the cycle. The soil does not mourn. It absorbs, adapts, and waits. Chemical signals move through the soil like thoughts. When one part of the forest is disturbed, by trampling, by fire, by flood, the change is noted in the soil's microbial communities. Some die, others flourish. These shifts ripple outward, like memories shared among roots. Over time, the soil itself changes, not just in structure, but in behavior. It remembers what came before. You scoop a bit into your hand, and notice its texture, not uniform, but layered with life. There are bits of lichen, traces of beetle husks, grains of sand, specks of charcoal. You're holding the past, not in fossil form, but in active breathing transformation. The forest doesn't build on blank space. It builds on history, and the forest listens to its soil. Some seeds will not germinate unless the soil has held fire. Others need the presence of specific bacteria, or a certain level of acidity, or even the faint trace of a root that once grew nearby. Germination is not just biology, it is permission. The soil must say yes. Even the scent rising from the ground after rain, that earthy sweetness, is part of memory. It's called petrichor, and it comes from oils released by microbes in dry soil when water returns. That smell is a signal. Water is here. Life can begin again. To us it may feel nostalgic. To the forest it is simply the turning of a page. You lie back and feel the heartbeat of the earth beneath your spine. It is not loud, it does not pulse, but it is there, a deep holding presence. The soil does not speak, but it remembers everything. What fell, what bloomed, what was lost, what was returned. And now, as you drift toward sleep, you feel that memory holding you too, not as a weight, but as a bed, soft, forgiving, ancient. The forest grows above, but it remembers below. It begins not with thunder, but with warmth. A rising exhale from the leaves. As morning sunlight spills into the canopy, the Amazon breathes. Every surface, leaf, bark, petal, pond, begins to release water into the air. This is transpiration, the quiet release of vapor from living things. It rises invisibly, not in rushes but in waves, millions of tiny sighs drifting upward together. You do not see them, but you feel the forest getting heavier, more humid, as if the sky itself is drinking from the trees. As the warm air ascends, it carries this moisture higher and higher. The temperature drops, and with it, the invisible vapor begins to slow, to gather, to cool. Microscopic dust particles, pollen, spores, even fragments of salt or smoke, float through the atmosphere like seeds waiting for purpose. Water clings to them, molecule by molecule, until droplets form around their tiny skeletons. These are the first cells of a cloud. From the ground it looks like nothing at first, just a haze, a pale blur in the blue. But the process continues, rising and compounding, the air growing thicker with moisture. In time the haze becomes shape, a cloud forms, and not just any cloud, a cumulus, full and white and soft, like a slow heartbeat suspended above the forest. Within it, countless droplets dance in suspension. Some grow heavy, some collide. And when the balance tips, the first drop begins to fall. This is the birth of rain, not just a cycle, but a story. The raindrop is not made for the forest. It is of the forest. It was once part of the river, or the breath of a frog, or the sweat of a leaf. Now returning from the sky, it prepares to fall, not as punishment, but as promise. Gravity pulls it gently downward. It slips through the cloud, gathering speed, brushing against other droplets, sometimes merging, sometimes splitting. It is not alone. The drop breaks through the bottom of the cloud. Light touches it, bending slightly, creating color. Sometimes, if the angle is right, A rainbow forms in the space between the fall and the ground, a soft arc of light carried on breath and water. But the drop doesn't pause to admire it. It falls. As it passes through the air, wind may stretch it, flatten it, send it sideways, but it holds together. It remembers. Beneath the forest waits. A single drop may fall 1,000 feet before touching a leaf. And when it does, the moment is gentle, but powerful. The leaf bends slightly under the weight. The drop may rest there for a while, a clear bead balanced in green. Or it may roll down the edge, into a fold, down the stem, along a branch, and finally fall again to the soil below. But this is only one journey. In a single rainstorm, millions of such drops are born, fall, scatter. Some are intercepted by the canopy and never reach the floor. Others trickle down tree trunks, seeping into the bark, nourishing mosses that cling like soft fur. Some drops find bromeliads and fill their cups, forming miniature pools where frogs will later lay their eggs. Others sink into the soil, joining the underground flow, becoming part of streams that snake beneath the roots. Still others will reach the river, slowly, eventually, joining currents that flow for thousands of miles, carrying the forest's breath back to the ocean. There, warmed again by sun, they will rise once more. The journey repeats, always forward, always homeward. You listen to the sound of it, rain touching leaves, leaves touching each other. No drop falls in silence. Every touch makes music, a whisper, a patter, a drumbeat. The forest does not weep in rain. It sings, it drinks, it remembers. And you lying beneath it all, feel the drops landing softly on your face, your arms, your breath, not cold, not heavy, just present. Each one a traveler, each one returning. Above the Amazon, there is a river that has no banks, no fish, no visible surface, yet it carries more water than the Nile. It does not wind through trees, but flows through the sky. This is the flying river, a vast current of water vapor carried on the wind, born from the breath of the forest itself. You cannot see it, but you feel it in the weight of the air, in the dampness on your skin, in the sudden softness before rain. The Amazon's trees act as pumps, drawing water from deep underground and exhaling it into the atmosphere. Through evapotranspiration, each tree releases hundreds of liters of water a day, and multiplied across billions of trees, the forest becomes a breathing ocean. As the moisture rises, it joins with heat from the ground, and forms the first threads of cloud. These threads stretch westward, lifted by trade winds, curling like soft steam over the Andes. Scientists have measured this airborne river. It moves billions of tons of water vapor every day, more than the Amazon River below. But this vapor does not simply vanish into the air. It feeds rainfall patterns across South America, Brazil's farmland, Argentina's grasslands. Even distant peaks in the Andes rely on the forest's flying breath. Without the Amazon, these regions would dry and shrink. The forest does not just feed itself, it waters continents, and the forest knows this rhythm. During the dry season, when rains lessen, the trees don't slow down, they accelerate their water release. As if calling out for clouds to return, they send more vapor upward, seeding the sky with their thirst. The flying river listens, forming storms above, and returning rain just when the forest needs it most. It's not a cycle of luck, it's a choreography of survival, written in steam and wind. This river is not linear. It bends, twists, meanders through high pressure and low, shifting its flow with every change in climate. When deforestation begins in one region, the flying river weakens, not only above the logged land, but far beyond starving areas downstream of their vapor lifeline. Rainfall drops, crops fail, fires increase, the system frays. The river in the sky depends not on clouds alone, but on the lungs of the forest still breathing below. You imagine standing on a high branch, looking outward, not at the forest but above it. You see tendrils of cloud forming in the afternoon heat, drifting and growing like thoughts. They are not idle, they are the movement of water in its most ethereal form. A sloth clings lazily below you. A hawk wheels silently overhead. Both depend on the invisible current flowing between them, the water that isn't water, the rain that hasn't yet fallen. This vapor current is also a memory carrier. It contains particles of pollen, dust, even trace scents. As it moves, it shares the chemical fingerprint of one forest with the air of another. Somewhere miles away, the smell of orchids may be whispered to the Andes. The sky becomes a messenger, a bridge, and when the flying river meets the mountains, it slows. The Andes rise like a wall, forcing the moisture to rise higher, cool and condense. Heavy clouds gather, rain falls, sometimes in torrents, sometimes in mist, but always the journey ends with a return. What rose from leaf and bark becomes again the lifeblood of roots and soil. You lie still, eyes closed, imagining the river above you. It has no sound, no color, yet its presence fills the sky, like breath fills lungs. You understand now. The rainforest is not just one ecosystem, it is a skywalker, a water weaver, a continent maker, and still, the flying river flows, silent, essential, alive. If you stand quietly beside a river in the Amazon, truly still, you might begin to notice that it breathes, not in the way animals do, with lungs or sighs, but in the silent lift of mist from water, in the invisible exhale of the earth. This is evaporation, the moment when liquid becomes air, when the river lifts a part of itself skyward in offering. And though it makes no sound, the forest listens. It always listens. Evaporation begins where warmth touches water. A ray of sunlight, gentle as a hand, stirs the surface of a pool. Some molecules, energized by heat, escape their liquid bonds and slip into the air. One by one, thousands rise like soft ghosts, not by force but by release. There is no splash, no ripple, only change. This is the forest's quietest transformation, and yet it sustains everything you see. The Amazon is not only rich in rivers, it is rich in evaporation. Its vast network of streams, puddles, wet leaves, mossy bark, and saturated soil creates a tapestry of surfaces, constantly releasing vapor. This steady lifting of water into the atmosphere creates a kind of humidity halo, thick, invisible, warm. You feel it in your lungs, on your skin, in the heaviness of the air. Every breath you take here tastes of water on its way somewhere else. Evaporation is not just a consequence of heat, it is part of the forest's design. Trees regulate how much moisture they hold, and how much they let go, using stomata, tiny pores on the underside of leaves. These microscopic mouths open and close, balancing gas exchange, moisture retention, and temperature. When the air is dry, they may shut tight, holding on. When it's humid, they relax, exhaling in soft rhythm. This breath is what keeps the forest moist, even when skies are clear. But evaporation is not uniform. On sunny days, it rises quickly, forming columns of warmth that draw in wind and eventually form clouds. On cloudy days, it slows, held back by the cooler air. At night, the heat held in the earth slowly releases, and with it a gentler mist creeps upward, not in plumes, but in veils. You can see it sometimes at dawn, floating low above the ground, catching first light like memory drifting above dreams. Animals respond to this breath too. Frogs wait for the air to thicken before calling. Insects time their emergence with the rise of dew. Even birds know, when the air grows heavy, the rain is near. Some species sing louder just before it begins, as if the breath of evaporation carries a promise written in steam. There is a sacred slowness to this process. The river does not rush to the sky, it lifts in patience. A single drop may evaporate, drift upward, and days later fall again, as rain, perhaps in another valley, on another leaf, beginning another cycle. The forest does not control where it lands. It only releases and trusts. And trust is important, because evaporation requires energy. Water must absorb heat to leave the surface, heat that cools the plant, the soil, the air. In this way, evaporation acts like a natural thermostat. On sweltering days, it prevents overheating. During droughts, it slows, conserving both moisture and warmth. It is a silent regulator, invisible, essential. You tilt your face upward, though you see nothing. The air brushes your cheeks with the softness of vapor. It carries the memory of river, of rain, of roots. Inhale deeply, and it is there, the ghost of water, the breath of the land, and when you exhale, you add to it, your own body returning moisture to the cycle. Nothing in the Amazon is wasted, not even breath. As daylight fades, the forest does not fall silent. It tunes itself. From the deep stillness of the understory, a single note emerges, a soft chirp, high and tentative. Then another, lower, more rhythmic. Within moments, the air fills with layers of sound, each one small on its own, yet together forming a living composition. This is not background noise. This is music. The symphony of the forest floor begins. You sit on a moss-covered log, the damp wood warm with the memory of sun, and let your ears do what your eyes cannot see. Every corner of the rainforest floor holds a musician. Tiny crickets with legs sharp as violin bows, leafhoppers that tap against dry bark like percussionists, beetles that rub wing against wing to hum into the night. Together they play an orchestra without conductor, without pause. The forest floor is not a place of grand movement. It is where stillness becomes language. Most creatures here are small, delicate, and well hidden, but their voices are enormous. A single katydid can be heard from 100 meters away. Its song, repeated tirelessly through the night, is part mating call, part location beacon, part heartbeat of the dark. Another insect, the mole cricket, burrows a tunnel that amplifies its sound, a natural megaphone dug into the earth. Unlike the birds and mammals above, these creatures rarely rely on vision. Down here sight is useless once the sun slips away. Instead, life unfolds through vibration, rhythm, repetition. The insects know each other's songs, not just by pitch or tone, but by pattern. Each pulse carries meaning, readiness, territory, warning, invitation. The forest is alive with intent, even if we cannot decode it. At your feet, a procession of leaf-cutter ants carries fragments of green back to their hidden city. Their movement makes no sound to your ear, but if you press your palm to the earth, you may feel the faint tremor, a vibration of purpose. Nearby, a chorus of frogs joins the song, their voices rising like bubbles in thick air. Some call from tree hollows, others nestle in the folds of bromeliads. Their notes add texture to the soundscape, wet, pulsing, alive. Above all, the cicadas reign. When they call, the entire forest seems to vibrate. Their song can rise in waves, deafening, then fall away like breath exhaled. It's not a scream, it's an announcement. I am here, we are many. The night belongs to us. Their bodies shake to create sound, and in doing so they shape the night. Even silence plays a role. Between calls in the soft spaces, you can hear the wind pushing through ferns, the fall of a single raindrop from a high leaf, the rustle of something small moving unseen. The quiet between sounds is not emptiness. It is pause, rest, breath, the heartbeat between notes in a lullaby. You begin to understand that this symphony is not random. It changes with the moon, with the rain, with the season. On dry nights the sounds are sharper, faster, more urgent. On wet nights deeper, more resonant, as water softens wings and wood. Some insects sing only on new moons. Others follow the tide of humidity. The forest floor is a living score, rewritten every night, and within it all, echoes drift not only forward but back. Certain notes trigger memories in others. A tree cricket hears a rival's call and matches it. A frog hears the soft click of wings and knows when to fall silent. The forest listens to itself. It adapts in real time, adjusting volume, tone, tempo. Lying on your back now, you feel the sound through your body, not as noise but as movement, vibrations through moss and bone. The forest doesn't perform for you. It performs because it must, to attract mates, to claim space, to be known in the dark. You close your eyes, and still, the music plays. Without light, it becomes even clearer. The rhythm, the repetition, the cycles, like breath, like tide, like sleep. This is not a performance. It is existence in harmony. The night deepens, and with it a language unfolds, not in words, not in light, but in a dance of sound, scent, and vibration. For the insects of the rainforest, communication doesn't require sight. In fact, it often thrives in the absence of it. As darkness settles over the forest floor and the canopy veils the moon, insects awaken into a world of pure sensation. Every wing beat, every pulse, every rub of limb against limb becomes a message sent into the night. You listen again more closely this time, and realize that the forest is not just full of sound, it's full of meaning. Crickets sing in repetition, their songs rising in smooth, deliberate patterns, but each species has its own tempo, its own frequency. One may trill in fast, sharp chirps, another may drone in slow, pulsing tones. No two overlap identically. This is not coincidence. It's an evolutionary strategy, a way of claiming space in the crowded soundscape, a way of saying, I am here without being mistaken for someone else. Communication in darkness relies on precision. Take the katydid, a green leaf-shaped insect that produces sound by drawing one wing across the other. The resulting rasp is like a violin drawn across silence. Some katydids produce ultrasonic signals, pitched above the range of human hearing, but easily detected by bats, their predators. To survive, many species use directional calls, whispering toward potential mates but remaining inaudible from above. It's a careful balance. Speak loudly enough to be heard by love, but softly enough to avoid death. Others speak through vibration. Tree hoppers and plant hoppers press their bodies against stems or leaves, and produce tiny tremors, seismic messages that travel through the plant itself. These aren't accidental movements, they're structured pulses repeated in distinct rhythms. A receptive female may feel the vibration and respond with her own. The two will trade signals until they find each other in the dark, connected by a path that never touched air. Chemical signals are just as crucial. Many moths, especially females, release pheromones into the night, invisible plumes of scent that drift on warm currents. A single molecule may travel meters, carried on the wings of a breeze. Males detect these scents with large feathery antennae, sometimes dozens of times more sensitive than any human nose. Following the gradient, they trace a chemical trail through space, narrowing in with every wing beat. It is not vision that guides them, but memory, wind, and desire. Some fireflies combine scent and light, flashing coded patterns from their abdomens. Each species has its own signal, a soft blink, a double pulse, a rising flicker. Males fly in search of the matching code. Females, hidden in grasses or perched on bark, respond in kind. Their entire romance plays out in flashes too faint to disturb the forest, but strong enough to build a bond. And yet, not all is tender. Some firefly species mimic the mating codes of others, luring unsuspecting males in not for love, but for a meal. In the dark, deception travels as easily as truth. Even silence is part of the conversation. Some insects stop calling when predators approach, creating sudden gaps in the soundscape. These silent moments ripple outward, warning others before danger is even visible. The forest learns to listen not just for what is said, but for what isn't. In this nocturnal world, boundaries blur, communication becomes art, science survival. All at once, signals layer upon signals. A cricket trills while a beetle scrapes its shell, while a moth releases its invisible perfume into the air already heavy with night. These aren't competing voices, they are a chorus, a weaving of intentions and instincts, each one shaped by millions of years of practice. You lie motionless, surrounded by the thick language of the unseen. You can't understand every signal, but you feel their weight in the air, their logic in the pattern, and more than that, you feel their necessity. The forest does not sleep in silence. It speaks more clearly when the sun is gone, and though you have no wings, no antenna, no leaf to tap, a part of you begins to hear, not with ears but with presence. Night in the rainforest is not a stillness, it is an architecture of echoes. With each passing hour the dark grows denser, yet somehow the forest becomes more defined, not by light, but by sound reflected and returned. Every call that goes out meets the trees, the leaves, the air, and comes back changed. In this way, the night reveals itself not through sight, but through resonance. You do not see the world, you hear its shape. At the heart of this acoustic tapestry are the bats, masters of the unseen. They weave through the branches in total darkness, navigating not with eyes but with echolocation. High-pitched chirps and clicks bounced off surfaces to map their surroundings. A bat emits a burst of sound so rapid, so sharp, that it returns within milliseconds, telling it exactly where a branch lies, where an insect flutters, where a rival swoops nearby. This isn't noise, it's geometry, felt in real time, but bats are not alone in this listening. Owls fly nearly silently, but their wide-cupped faces are designed to capture the smallest rustle of prey on the forest floor. Frogs use the bounce of their own croaks to sense depth in water. Even certain insects, like bush crickets and moths, can detect reflected sound, allowing them to adjust position or flee before a predator's strike. These are not just reactions, they are strategies built on echo. You sit beside a still pool, listening. Insects trill, frogs sing, a monkey far in the canopy calls once, then listens. The sound returns differently, shaped by the distance, by the moisture in the air, by the leaves in its path. This altered return carries information. How far, how dense, how wet. Every sound that travels here becomes a mirror, one that reflects more than shape. It reflects context, timing, possibility. Humans are deaf to much of this range. The forest speaks in pitches we cannot hear, in frequencies too high or low for our perception. But the creatures of the night know. They design their calls to bend and twist around obstacles. Low rumbles carry far through the undergrowth. High notes bounce better in cluttered air. A single chirp, strategically placed, can echo a map of the entire terrain. Sound becomes terrain. Echo becomes direction. Even plants, in their own slow rhythm, respond to vibration. Some studies suggest roots grow differently when exposed to repeated sound, seeking toward water frequencies, turning away from mechanical ones. Fungi, too, may alter growth based on sonic exposure. It seems the forest is not only full of echoes, it is shaped by them. Then there are the false echoes, sounds created by mimicry. Some insects imitate bird calls, some birds mimic insect calls. A few frogs copy the chirps of more poisonous species to avoid predation. The dark is full of borrowed voices. The forest, ever adaptive, builds its identity from this chorus of borrowed truths. You realize that what you hear is not simply what is there, but also what others want you to believe is there. Echo in the rainforest becomes disguise. There is no pause, only layering. As one creature falls silent, another begins, and beneath it all, the background rhythm continues. The low thrum of insects, the drip of water on stone, the pulse of life repeated through time. Each return of sound is a recalibration, a reassurance. You are not alone. You close your eyes and feel the night as a soft pressure, not on your skin, but in your chest. Each sound returns to you slightly altered, and yet deeply familiar. Even your own breath begins to echo. You inhale, pause, and listen to the space your body creates in this shared acoustic map. The darkness is no longer empty, it is full of return. In the heart of the rainforest, where time seems to slow and the air grows thick with stillness, the act of breathing is not limited to lungs. Here, trees breathe light, slowly, gently, endlessly. Every leaf you see is a lung, and every patch of green is a mouth open to the sun. Through the soft alchemy of photosynthesis, the forest transforms light into life, but not in haste. The process is patient, deliberate, a slow unfolding that has shaped this world for millions of years. Photosynthesis begins with a photon, a tiny weightless particle of sunlight that travels 150 million kilometers from the sun, only to be caught in the green pigment of a leaf. Chlorophyll. The photon is absorbed, not with violence but with welcome. It excites an electron within the leaf cell, setting off a cascade of energy. This energy is used to split water molecules, drawn up through the roots into hydrogen and oxygen. The oxygen is released, exhaled into the air. The hydrogen is used along with carbon dioxide drawn in from the surrounding atmosphere to build sugar. This sugar becomes food, fuel, structure. It becomes the tree. The whole process sounds scientific, and it is, but standing here surrounded by leaves of every shape and shade, it feels more like devotion. Each tree performs this act of quiet service daily, without complaint or praise. Each leaf balances light and shadow, warmth and water. A tree does not photosynthesize with greed. It does not take more than it needs. It breathes in carbon dioxide, the very gas that chokes our atmosphere, and breathes out oxygen in return. It is an exchange, a silent agreement between sky and root. In the lower layers of the forest, where sunlight barely reaches, photosynthesis becomes even more reverent. Plants here must make do with fragments of light, flecks, rays, shimmering traces that drift down through the canopy like forgotten coins. These plants adapt. Their leaves become larger, thinner, richer in chlorophyll. They catch whatever they can, even in near darkness. Their photosynthesis is slower, but no less sacred. A single photon may travel hours before being absorbed, a journey from sun to sugar, held in the green palm of a low-growing fern. You press your hand to a leaf and feel its texture, smooth, damp, slightly warm. Beneath the surface, microscopic chloroplasts are working, tiny factories turning light into energy. Even now, as clouds drift overhead and the light dims, the process continues, quietly adjusting. There is no panic, no pause, only rhythm. In the larger trees, photosynthesis powers not just growth but generosity. Trees produce more sugar than they need, and they share it, down through their trunks, into the soil, through the fungal networks that connect them to other trees. Even dead trees, still upright, pass on sugars through these connections. The forest does not hoard energy, it circulates it, like breath, like story. And when night comes, the process does not vanish. It rests. The pores of the leaves close, the chloroplasts wait. The tree exhales quietly and turns inward, conserving what it has made. The sugars created in the light are used to build cell walls, to stretch roots, to repair wounds. Growth, though invisible to the eye, continues in the dark. Photosynthesis is not just a reaction to sunlight, it is a rhythm stitched into the forest's body, pulse by pulse, leaf by leaf. You look up and see a single shaft of light piercing through the canopy. It lands on a young sapling, whose leaves tilt instinctively toward it. There is no struggle, only alignment. The plant adjusts to the gift, and within that still moment, the sun becomes food, the air becomes future. The forest breathes again. You've heard that trees give us oxygen, but perhaps you haven't yet understood this deeper truth. They breathe with us, not for us. In the quiet spaces of the forest, far from machines and thought and rush, the exchange of gases becomes a kind of communion. Every breath you take, even here beneath the greenest canopy, is mirrored by something rooted in the soil, something older than thought. This is respiration, and it happens not just in lungs, but in bark, leaf, moss, and root. Unlike photosynthesis, which happens only in light, respiration continues endlessly, even through the night. It is the process by which a tree, having stored sunlight as sugar, begins to spend it. Inside the cells of every living thing, trees, insects, fungi, sugar is broken down in the presence of oxygen. The result is energy, heat, breath, and the quiet release of carbon dioxide. During the day, photosynthesis dominates, soaking up carbon dioxide and releasing oxygen. But in the hush of night, the balance shifts. The tree consumes some of that oxygen and gives back carbon dioxide in return, not as pollution but as presence. It is a gentle cycle, one of give and take, woven into the forest's every hour. You place your hand against a tree's bark and wonder what it remembers. Beneath the surface, millions of cells are quietly working. Sugars, created days or even weeks ago, are moving through the phloem, the tree's inner veins. Some travel to the roots, feeding the invisible life below. Some rise to the highest leaves, fueling repair and new growth. Respiration allows this energy to be released, not in flashes, but in flow. And the carbon released is never wasted. Microbes in the soil absorb it. Fungi use it. Nearby plants may draw it in again by morning. In this forest, carbon is currency, traded, recycled, held in the bodies of trees for decades, even centuries. A single old tree may store more carbon than an entire meadow. Its trunk is a vault of breath, held in wood, but nothing is permanent. When a tree dies, the carbon returns. Through decay, through fire, through the mouths of insects and fungi, the tree is slowly dismantled, not erased, but redistributed. The carbon enters the soil, the air, the bloodstream of new plants. What was once solid becomes vapor. What was once rooted becomes motion. Even the air you exhale now, sitting in this forest, may hold atoms once exhaled by a tapir, or a jaguar, or a tree, struck by lightning 100 years ago. In the carbon exchange, time blurs, and it is not just trees that breathe. The forest floor exhales with every heartbeat of its microbial world. Fungi respire, insects respire. Even the soil itself, rich with life, produces carbon dioxide as organisms break down organic matter. On warm, moist nights, this respiration can surpass the tree's own intake, making the forest a temporary carbon source instead of a sink. This is not failure, it is balance. Every breath out invites a breath in, every rise has its fall. As climate warms, this balance teeters. Increased temperatures can accelerate respiration, causing forests to release more carbon than they store. This change, invisible to the eye, shifts the rhythm of the entire system. A forest that once held breath begins to lose it, and yet here, in this moment, it still breathes with you, calmly, evenly, ancient. You inhale. Oxygen from a leaf that caught the sun 2 days ago fills your chest. You exhale. Carbon, built from your food, your cells, your thoughts, returns to the air, where a fern or a tree or a patch of moss may soon receive it. There is no loss here, only movement. Breathe again. This is the forest's quiet agreement. I give, and you return. I take, and you offer. Together we exist in rhythm. Leaf to lung, root to rib, ancient to present. When people say that trees are the lungs of the earth, it's often said with good intention but vague understanding. The truth is more intricate, more poetic, more precise. Trees do not just breathe, they regulate the planet's breath. Every leaf is a lung, every forest is a diaphragm, and the Amazon, vast and dense, is a breath held long and deep. Exhaling life, inhaling memory. Imagine standing in the center of the Amazon basin. The air is heavy with mist, the scent of wet bark, crushed leaves, and unseen flowers. You take a breath. The oxygen you draw into your lungs may have been released just moments ago by a tree nearby. Its stomata opened like tiny mouths on the undersides of leaves. These microscopic openings allow carbon dioxide in and oxygen out, a silent exchange performed billions of times across the canopy every second. This is photosynthesis, yes, but on a scale too grand for numbers. It is planetary respiration, written in green. During the day, the forest is a net carbon absorber. Trees draw in carbon dioxide and store it as wood, roots, and leaves, locking it away for years, decades, even centuries. This stored carbon is what allows trees to stand tall, their trunks rigid with the memory of ancient air. When you press your palm against a tree's bark, you're touching more than structure. You're touching breath, frozen in form. But the lungs of the planet don't just filter air, they regulate temperature. Through evapotranspiration, trees release water vapor, which cools the surrounding air, forms clouds, and helps stabilize rainfall patterns, both locally and far beyond. Without forests, air would grow hotter, drier, more volatile. The Amazon alone influences weather as far as the southern United States, the Andes, even parts of Europe. Its breathing shapes climates, bends wind patterns, creates rain, and it listens. When global carbon levels rise, trees grow faster, pulling more from the atmosphere in an attempt to restore balance. But they can only do so much. In recent years, scientists have discovered that portions of the Amazon are becoming carbon neutral or even carbon sources due to deforestation, fires, and stress. When the lungs are damaged, the breath becomes shallow, the rhythm stutters. Yet for now, much of the forest still holds. Ancient mahoganies, towering sabers, sprawling kapoks, they rise above the canopy like lungs full of purpose. Each holds tons of carbon within, but more than that, they hold continuity. These trees remember floods and droughts, eclipses and migrations. Their rings tell time, their roots hold soil, their leaves sift the sun. Even dead trees, fallen and rotting, continue to breathe. Through the work of fungi, bacteria, and insects, the carbon they held is slowly released back into the cycle, not all at once, but gently, as if exhaling over years. The forest wastes nothing, not even stillness. And you, lying on your back beneath a crown of branches, feel the truth of it in your lungs. Your breath matches the pulse of the trees. The oxygen filling your chest has been filtered through green veins. You are not outside the system, you are part of it. Each inhale is a gift from something rooted. Each exhale is a return. Close your eyes, the forest is breathing, so are you. When rain falls in the Amazon, it does not simply drop. It descends with memory, guided by design, a choreography shaped by millions of leaves, branches, and trunks. This forest is not just a passive recipient of rain. It is an architect of its own rainfall, sculpting how water moves, where it lands, how it is held, and how it is released. Each tree, each leaf, each patch of moss contributes to a delicate and deliberate system, a living structure built not from stone or metal, but from light, water, and time. You feel it first on your skin, the warmth in the air thickening, the light dimming softly. A hush begins, not from silence but from expectation. Then comes a single drop, wide, heavy, caught by the curve of a leaf above you. It rests there trembling until its weight overcomes balance, and it falls again, slower, softened, landing on another surface below. Rain in the Amazon is layered, filtered through levels of green before ever touching the earth. What seems like a downpour in the sky becomes a whisper by the time it reaches the forest floor. The canopy, that high roof of interlocked branches and broad leaves, acts as a first filter. It breaks the speed of raindrops, catches the largest ones, disperses the force, leaves angled downward like green umbrellas, allowing water to run along veins and drip gently from their tips. These tips are not accidental. They are structures called drip tips, evolved specifically to channel rainwater away from the leaf's surface and prevent fungal growth. With each drop that leaves the tip, a rhythm begins, tap, 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 a symphony in slow motion. Beneath the canopy lies the understory, where smaller trees and shrubs continue the work. Here leaves are often broader and arranged in precise angles to catch what escapes from above. Some even form miniature bowls, pooling rain for insects, frogs, or thirsty birds. Water doesn't just fall, it is held, tasted, shared. The forest becomes a sponge, not just absorbing moisture, but redistributing it, ensuring life at every level. Then slowly, the water reaches the forest floor, not in torrents, but in a soft cascade. Mosses, fungi, leaf litter, and soil work together to slow the rain, drawing it downward into the earth, where roots await. The soil, rich with organic material, swells gently, absorbing what it can. The rest moves horizontally, flowing into micro streams, small creeks, and finally, into the rivers that lace the forest like blue veins. Nothing is wasted. Every drop has purpose. But the architecture of rainfall is not just about slowing, it is also about guiding. The way trees lean, the angles of leaves, the positioning of bark and stem, all these elements direct water. Some trees have smooth bark to encourage runoff. Others have deep grooves that channel water toward roots. Vines and lianas help move water sideways across trunks. Even epiphytes, plants that grow on trees rather than in soil, catch and store rain, forming miniature reservoirs high in the branches. Within them small ecosystems thrive, tadpoles, beetles, even snakes. Rainfall in the Amazon is not just weather, it is part of the forest's design language. The timing, too, follows a pattern, often in late afternoon, after a day of evapotranspiration. Clouds build to bursting, thunder may roll low and deep, like a warning or a song, then a release, warm rain, fast but soft, lasting just long enough to soak everything in gratitude. And when it ends, the forest does not rush to dry. Steam rises from bark, leaves glisten with memory, water clings to web and wing. The air itself becomes a carrier of moisture, prolonging the gift even after the clouds move on. You lean against a trunk and feel the bark still wet beneath your fingers. The ground smells rich and clean. Above, droplets still fall, long after the storm has passed, not from sky, but from leaf to leaf to leaf. A slow, generous echo of the rain. This is not randomness. This is intention. The forest builds for rain the way lungs are built for air, and you, breathing it all in, realize you're standing inside a cathedral made of water and wood, where rain is not just weather, but worship to the casual eye. A leaf may seem simple, green, flat, silent, but in the Amazon, a leaf is an instrument in the great symphony of rain. It does not simply exist. It listens, it catches, it redirects, it bends to storms, and lifts to mist. It composes and conducts the flow of water through its shape, its tilt, its texture. Each one is tuned to a specific purpose, adapted over generations, to not just survive the rain, but to play with it. You stand beneath a tree and look up. What you see is not chaos, but arrangement. Leaves are staggered to avoid blocking each other, forming layers that allow rain to pass smoothly from top to bottom. This design is called phyllotaxis, the mathematical pattern in which leaves grow, spiraled, alternating, opposite. Each arrangement creates space and exposure. No two leaves compete for the same light or the same drop. They share the rhythm. As rain begins to fall, you watch how the leaves respond. The water lands not with splashes, but with precision. Broad leaves cradle it briefly, then channel it down their central vein toward a tip. That tip, often narrow and extended, creates a clean path for the water to fall, and a droplet, a single note in the rain's melody. These tips, known as drip tips, are not decorative. They serve a critical function. They shed water quickly to prevent the growth of mold and bacteria, which thrive in prolonged moisture. Some leaves are waxy, allowing water to slide off in perfect beads. Others are slightly hairy, holding water longer for absorption or for small creatures to drink. The surface texture matters. The angles matter. Even the flexibility of a leaf is tuned. It must be strong enough to hold its place in wind, but soft enough to bend and spill water gracefully, avoiding breakage. You begin to see that every leaf is both architect and musician, shaping water while being shaped by it. Rain does not only fall on leaves, it plays them. Each droplet strikes a different surface, creating a range of sounds: soft pats on thick leaves, high plinks on thin ones, whispers on moss. The forest becomes a percussion orchestra, conducted by gravity, with the trees as its instruments. You close your eyes and hear it, not noise but arrangement. Each beat is placed, spaced, echoed, beyond their shape and sound. Leaves also redistribute rainwater. Some trees, like the cecropia, direct water toward the base of their trunks, allowing it to trickle down to their roots. Others angle their leaves outward, helping to nourish neighboring plants and seedlings. The water that hits a single tree may end up feeding a dozen others. In this forest, water flows with intention and generosity. Epiphytes, plants that live on the surface of other plants, rely on leaf architecture to survive. Many grow in the cradles, formed where leaves meet branches, catching runoff like cups. Bromeliads, in particular, form rosettes that hold rainwater in central wells, creating miniature ponds. Insects, frogs, even small snakes may live their entire lives in these leafy reservoirs. A single leaf may hold an entire ecosystem, suspended in green. In some cases, the leaves themselves create water. Through a process called guttation, certain plants release excess moisture through special pores, usually in the early morning. Tiny droplets form on leaf edges, not rain but sweat. These droplets contribute to the forest's humidity, feeding back into the cycle of evaporation, condensation, rainfall. Even when it isn't raining, the leaves remember how to weep. You run your fingers along the edge of a large banana leaf, tracing the curve where water would gather and flow. You can almost feel the memory of 1,000 rains etched into its veins. It has guided more water than you will drink in your lifetime, not in floods, but in countless small releases, precise and patient. And in this moment you understand, the rainforest doesn't endure rain. It welcomes it. It shapes it. It sings with it. Beneath the dripping leaves and soaked bark of the rainforest, life stirs where no eye can follow, not among the monkeys or birds, but in the microscopic realm, in the layers of moisture that cling to everything, everywhere. The air in the Amazon is more than humid, it is alive. Every drop of rain that seeps into soil, every bead of water that lingers on a leaf, becomes a miniature universe for the smallest inhabitants of the forest, microbes. And while they are too tiny to see, their role is vast, essential, constant, and quietly miraculous. When moisture saturates the forest floor after rain, it awakens dormant bacterial colonies in the soil. Spores that lay in wait for the right moment suddenly stir, sensing water as both invitation and fuel. These microbes begin to feed on decaying matter, fallen leaves, dead insects, rotting wood. Through this process, they break complex organic material down into simpler forms, releasing nutrients like nitrogen, phosphorus, and potassium back into the soil. It's an invisible transformation, one that underpins every tree, every fern, every vine that rises from the earth. But it's not just decomposition. Moisture also enhances symbiotic partnerships. Certain bacteria fix nitrogen from the air, converting it into a form usable by plants, a gift exchanged in the quiet chemistry beneath your feet. In return, the plants provide sugars produced by photosynthesis. It is an ancient agreement, older than rainforests themselves, kept alive by water. Above the ground, moisture clings to bark, moss, and lichen, forming what scientists call a phyllosphere, a thin, wet layer on leaf surfaces where thousands of microbial species reside. Some of these microbes protect the plant by producing antibiotics that deter pathogens. Others help in capturing nutrients from rainfall, even breaking down harmful pollutants. The leaf becomes not just a surface but a host, a living landscape where microbes graze, shield, and serve. Mosses and liverworts, especially in the wetter understory, act as microbial sponges. These plants retain water long after the rain ends, sustaining microbial life during dry spells. Inside each moss cushion, entire communities of protists, bacteria, and fungi thrive, interacting in complex ways. Some feed on algae that bloom in the moisture, others compete, others cooperate. To us it's quiet green, to them it's a metropolis. The fungi, ever present and ever indispensable, also flourish in this wetness. Their mycelial threads stretch further when hydrated, reaching deeper into soil, connecting roots to nutrients. Some species even wait for exact moisture levels before fruiting. A precise combination of humidity, temperature, and organic material triggers their emergence. The mushrooms you see rising after rain are not sudden miracles. They are answers to hidden calculations, whispered through water. Moisture is not just a trigger for growth, it is a medium of exchange. It carries dissolved minerals, nutrients, spores, and chemical signals. One patch of moist soil may communicate with another through water-transported compounds, shifting microbial behavior across unseen distances. This is how balance is maintained, how disease is fought, how cooperation spreads. And yet the rainforest remains delicate. Too much rain can wash microbes away, too little, and communities collapse. The forest lives in hydrated tension, managing its water like breath. Even the air is part of the system, saturated with microscopic droplets that harbor airborne bacteria and fungal spores. When rain falls again, these are brought back to the earth, renewing the microbial world with each cycle. You crouch low, touch the wet soil, and lift it to your nose. It smells deep, warm, ancient, the scent of microbial life at work. That earthy perfume, known as geosmin, is released by bacteria in wet soil. It's the forest's way of reminding you that even now, unseen hands are shaping the ground beneath you. So you rise, knowing that beneath every step, within every drop, a hidden labor continues. Invisible life, endlessly active. Moisture is their sky, their river, their breath. And with the next rain, the symphony will begin again, not just on leaves and branches, but in the microscopic world that holds the forest up from below. Inside every leaf of the Amazon, no matter how small or hidden beneath the shadows of taller trees, there exists a quiet miracle, a tiny green organelle known as the chloroplast. This is not just a structure, it is a storyteller, a translator, a weaver of light into life. When the sun spills through the high canopy and touches the surface of a leaf, it is not merely warmth that arrives, it is language, and the chloroplast listens. These microscopic factories float gently inside the cells of plant leaves, each one filled with chlorophyll, the pigment that captures sunlight. When a photon reaches the leaf's surface, it passes through the cell wall like a knock on a door. The chloroplast responds instantly. That light, born in the heart of a star, traveling across space for over 8 minutes, is absorbed and transformed. In that moment, energy from the cosmos becomes sugar, becomes fuel, becomes tree. It's a conversation so ancient and so elegant that it continues without pause, leaf after leaf, hour after hour. But this process isn't one of hunger or greed. The chloroplast does not hoard light. It works only when the conditions are right, when water is present, when carbon dioxide is near, when the temperature allows the reactions to flow. It is not a machine. It is a listener, a participant in the forest's rhythms. It slows when clouds pass, waits patiently through darkness, then awakens again with each sunrise. Each chloroplast is enclosed in a double membrane and filled with stacked disc-like structures called thylakoids, where the real work of light absorption occurs. These structures are incredibly efficient, organizing proteins and pigments with a precision that human engineers still marvel at. Within them, sunlight splits water into hydrogen and oxygen, the latter released into the atmosphere as a gift, while the former begins a journey toward building sugars. This sugar is not just nourishment for the plant. It's shared with fungi, with roots, with insects, with us. In the Amazon, chloroplasts must be adaptable. Light in the rainforest is not steady. It arrives in bursts, flickering patches that move with the wind, brief windows between cloud cover, shifting rays filtered through the dense architecture of branches. To survive, many plants have evolved to shift their chloroplasts within their cells, repositioning them throughout the day to capture the best angles. Some cluster near the surface when light is faint. Others retreat deeper into the cell when sunlight becomes too intense. It's a gentle dance, light and leaf adjusting to one another in real time. Even the color of a leaf can reveal its chloroplast strategy. In deep shade, leaves appear darker green, a result of higher chlorophyll concentrations, making each chloroplast a bit more sensitive, a bit more hopeful. In brighter areas, leaves may carry additional pigments, like carotenoids and anthocyanins, to protect the chloroplasts from sunburn. Every shade is a signal. Every hue is an adaptation. The sugar produced inside the chloroplast does not stay long. It is quickly moved through the phloem, the plant's transport system, where it fuels everything from root growth to flower production. It even becomes the building block for the plant's cell walls, meaning the very shape of the forest is carved by these tiny green artisans. A vine's curl, a seedling's stretch, the bend of a branch, all emerge from energy first captured in chloroplasts. But perhaps the most astonishing truth is this: the chloroplast wasn't always part of the plant. Billions of years ago, it was a free-living organism, a kind of blue-green bacterium, capable of photosynthesis. At some point it entered a larger cell, and began a partnership so successful, so harmonious, that it remained. It became part of the cell's family, passed down through generations, not as an outsider, but as kin. This ancient symbiosis still lives in every leaf. You hold a single leaf in your hand, and know that inside it, thousands, maybe millions, of chloroplasts are at work. Tiny, tireless, gentle. They ask for nothing more than light, and offer oxygen, sugar, beauty in return. You breathe, and a gift from chloroplasts fills your lungs. The forest is not just filled with leaves. It is filled with quiet suns, multiplied and softened, capturing light and turning it into life. A leaf is not simply green, that is only its first language, the most visible note in a symphony of colors that plants use to express their needs, their strength, their warnings, their desire. In the Amazon, where light is scarce and competition intense, pigments are messages. They do more than make leaves beautiful. They allow plants to communicate with the sun, with each other, with insects, even with the air around them. The dominant green comes from chlorophyll, the pigment responsible for capturing light. But not all light is treated equally. Chlorophyll absorbs blue and red wavelengths, while reflecting green, a byproduct of photosynthetic efficiency. This isn't just a color, it's a signal. A green leaf says, "I am photosynthesizing, I am alive, I am at work." But when chlorophyll breaks down, due to age, stress, or seasonal shift, other pigments rise to the surface, revealing messages long hidden beneath the green. One such group of pigments is the carotenoids, responsible for yellow, orange, and amber tones. These pigments protect the chloroplasts by absorbing excess energy and neutralizing free radicals produced by intense sunlight. They are the leaf's sunscreen, guarding against damage while keeping photosynthesis steady. When you see a leaf tinged yellow, it doesn't always mean decay. It may be adjusting, protecting itself, adapting in quiet defiance of too much light. Then there are the anthocyanins, which paint leaves in reds, purples, and deep blues. These pigments can appear in new growth, in response to cold, or as a defense against herbivores. The red coloration in young leaves, common in some Amazonian species, acts as a camouflage, tricking insects into thinking the leaf is tough, mature, and unpalatable. Sometimes, red is a warning, sometimes it's a veil. These colors also influence the behavior of animals. Bees, for example, are drawn to specific wavelengths, reflected by pigments, ultraviolet patterns, invisible to us, but clear as road signs to them. Flowers signal their readiness for pollination, not through scent alone, but through pigment shifts that guide bees and butterflies to nectar. Once pollinated, the colors fade or change, informing visitors that the job is done. It is a conversation in color, precise and evolved. Even within the leaf, pigment placement matters. Some plants layer pigments differently on the upper and lower surfaces of their leaves, adjusting their reflectivity and absorption based on where they grow. A leaf in deep shade may have purple undersides, bouncing low light back into the leaf to maximize photosynthesis. Others develop silvery coatings or variegation to deter pests or reflect heat. These aren't aesthetic accidents, they're biological signals, shaped by centuries of interaction with the environment. Pigments also fluctuate throughout the day. As sunlight shifts, so do the plant's strategies. Some species can adjust the concentration of protective pigments in real time, almost like pupils dilating. This dynamic flexibility allows plants to adapt hour by hour, shielding their inner tissues while still performing their essential work. But the language of pigments isn't always visual. Many are precursors to chemical signals, involved in sending distress messages or initiating self-repair. When a plant is wounded, pigment molecules can trigger the production of defensive chemicals, tannins, alkaloids, or aromatic compounds, which discourage predators or seal damaged areas. In some cases, pigments play a role in allelopathy, the suppression of nearby plants through chemical release. A message not of harmony, but of space. You reach out and run your fingers over a leaf that gleams faintly red beneath the green. Its surface is warm, slightly fuzzy, holding more than color. It holds intention, a signal meant for sun and insect, for heat and water. You are not its target audience, but you are allowed to witness. In this rainforest, color is never passive. It's a medium of survival, an ancient silent script that tells stories of resilience, of adaptation, of presence. And the next time you see a leaf, you will not see green alone. You will see layers of language, each hue a phrase in the long, patient dialogue between plant and world. In the hush beneath the canopy, where footsteps are softened by moss and air clings close with moisture, the rainforest speaks in signals, quiet messages exchanged not in sound, but in chemistry, in color, in shifts of movement too subtle for hurried eyes. Survival in this dense competitive world depends not on strength alone, but on the ability to perceive, adapt and respond. And plants, though rooted and silent, are among the most masterful communicators of all. The first signals are internal, a kind of self-awareness. When a leaf is touched, even lightly, its cells react. Mechanical stimulation triggers changes in ion flow, which ripple outward like electrical whispers. In sensitive plants like Mimosa pudica, the leaves fold immediately, a reflex evolved to deter herbivores or dislodge insects. But even in less dramatic species, touch matters. The very pressure of rain, the weight of a crawling insect, or the gentle bend from a breeze, can shape how a plant grows. Stems thicken, branches redirect, growth becomes response. Chemical signaling is even more profound. When a leaf is damaged, bitten, torn or infected, it releases volatile organic compounds, VOCs, into the air. These aren't cries of pain, but scented warnings. Nearby leaves on the same plant may begin to produce defensive chemicals even before they're touched. Neighboring plants too detect the airborne signal and prepare. Some may thicken their leaves, others increase toxins. A tree does not suffer alone, it sends out a message. Danger is here. Roots signal in darkness. Through the mycorrhizal networks beneath the soil, plants share chemical cues about nutrient availability, drought stress, or root crowding. A tree may slow its growth if its neighbor is struggling, or it may redirect resources through shared fungal bridges to support saplings or relatives. These choices are not emotional. They are evolved strategies, built on millions of years of trial and response. But signals are not only defensive, they are also invitations. Flowers produce color and fragrance not just to please, but to guide. Petal shapes and patterns serve as maps, directing pollinators toward nectar, and in doing so ensuring the plant's reproduction. Some orchids emit scents that mimic the pheromones of female insects, luring males into false mating attempts that leave them dusted with pollen. In this forest, deception can be survival too. Fruits ripen with another signal. Color change. Unripe fruits remain green, blending into foliage, but when their seeds are ready to disperse, the skin turns bright, yellow, red, orange. These hues attract birds and mammals, who in consuming the fruit, carry seeds far from the parent plant. Even the timing of ripening is strategic, synchronized with seasons, with animal migrations, with the rhythms of rainfall. It is not random. It is choreographed patience. Some signals are silent barriers. The waxy coating on a leaf might seem inert, but it can deter water loss, block fungal spores, or contain antimicrobial compounds. Thorns and spines, visible messages of caution, often accompany plants that carry potent chemical defenses. Their presence says plainly, look but don't touch, and for those who do touch, an unspoken contract is enacted. Perhaps the most extraordinary survival signal is one of memory. Plants exposed to stress, drought, cold, predation, often become more resilient in the future. Some even pass this resilience to offspring through epigenetic changes, chemical markers on their DNA that inform the next generation. The world is dangerous, be ready. In this way, survival is not only personal, it becomes inherited knowledge, layered silently into seed and root. As you sit beneath a strangler fig, wrapped tightly around its host tree, you realize that even this slow conquest is a form of communication. The fig has sensed the presence of another's trunk, responded with directional growth, adjusted its strategy over years. There is no haste, no cruelty, only a message written in shape and persistence. The forest does not shout, it signals. In every drop of resin, every curl of tendril, every flush of color, a story unfolds, one of survival, of adaptation, of quiet mastery. And now as you breathe the thick, fragrant air, your body too becomes part of the system, absorbing signals you cannot name, learning a language that predates speech. Beneath your feet, the Amazon does not sleep. It stirs, it swells, it teems. Though the forest above may draw your eyes upward toward parrots in flight, sunlight through canopy, vines that twist like questions, the real pulse of life begins in the dirt. The soil here is not dead matter, it is a universe, and every handful of it holds more living organisms than there are humans on the planet. You kneel and press your fingers into the soft, damp earth. It clings to your skin, warm, fragrant, complex. In that single pinch of soil lives a hidden community: bacteria, fungi, protists, arthropods, nematodes, and others too small to name or even see. Some are ancient, some are newly born. All are working, digesting, tunneling, signaling. This is the rainforest's foundation, its silent foundation, and the source of all its abundance. The bacteria are tireless. They break down organic matter, leaves that fell days ago, wood decaying in slow layers, the bodies of insects, even the waste left by animals moving above. In doing so, they release nutrients that plants need: nitrogen, phosphorus, potassium, and countless micronutrients. But these aren't dumped. They are released in balance, timed to demand. The forest, it seems, listens to itself even here, at the microbial level. Then come the fungi, the forest's great recyclers. Their mycelium threads snake invisibly through the earth, digesting complex material like lignin and cellulose. Without them, dead wood would pile endlessly. Fungi don't just feed, they connect. Their networks tie trees together, passing nutrients from the strong to the weak, the old to the new. In the dark, fungi stitch the rainforest together. Scattered through this world are the nematodes, tiny worm-like creatures that slide through soil water. Some feed on bacteria, some on roots, others prey on one another. To us they seem trivial, but in the Amazon they form the middle links in a long, invisible food chain. Each one is both consumer and consumed, and their presence helps regulate microbial populations, preventing chaos in this microscopic city. And then there are the arthropods, springtails, mites, beetle larvae, ants. They chew, shred, carry. They aerate the soil as they move through it, creating pockets that allow air and water to reach roots. Some ants cultivate fungal gardens underground, feeding it with chewed leaves. Others act as scavengers, cleaning the ecosystem grain by grain. Each movement, each bite, contributes to the health of the whole. Even protists, single-celled organisms that float through the soil's thin films of water, play their part. Some are photosynthetic, others feed on bacteria. Their populations can shift rapidly with moisture and temperature, creating a fast response system for ecosystem change. They are tiny, yes, but vital, forming the base of the microbial food web. But life here is not only about decay, it's also about defense. Certain microbes in the soil produce natural antibiotics to protect their territory. Others secrete chemicals that ward off pests or suppress harmful fungi. Plants sense this. They grow stronger in the presence of beneficial microbes, forming partnerships that improve immunity. Some soil bacteria even trigger root growth or flowering through chemical cues, acting like coaches, guiding plants toward their potential. The rainforest's surface is lush because its underground is alive. A fallen seed does not simply land and grow. It depends on this invisible world, on friendly fungi to help it take root, on bacterial activity to unlock the nutrients it needs, on gaps in the soil made by worms and ants, so that its first roots can breathe. Germination is not only biology, it is community. You breathe deeply and realize the air itself, rich in scent, in warmth, is shaped by what happens underground. Geosmin, that sweet earthy smell after rain, is released by bacteria. Even the humidity above your head is partly exhaled by the soil's organisms, through respiration, through moisture release, and all the while the cycle continues. Leaf falls, microbe feeds, root absorbs, life returns. You rise slowly, knowing now that every step you take here rests on a world more crowded than the stars, more vital than the canopy, more ancient than the trees. It does not speak aloud, it does not seek attention, but without it, nothing would grow. The forest lives by letting go. Nothing here clings to permanence. Everything, tree, leaf, fruit, even bone, is meant to fall, to return, to feed. This is not loss, it is transformation, and at the center of it all, quietly and invisibly, is decomposition, the sacred undoing that allows everything else to begin again. You walk through the forest after rain, and the ground beneath you feels alive, soft with moisture, warm with decay. Fallen branches lie dark and crumbling, blanketed in moss and fungi. Leaves form layers so thick they seem to melt into one another. In this layered floor, nutrient cycles hum like breath, steady and unseen. Every bit of matter here, from the highest canopy to the lowest root, will pass through this soil eventually, and when it does, the forest will reclaim it. Decomposition starts the moment something dies. A leaf, for example, begins to break down before it even touches the ground. As it falls, microbes on its surface, bacteria, yeasts, fungi, start digesting its outermost tissues. Once it lands, the work accelerates. Earthworms pull it down into tunnels. Fungi send out hyphae that creep across its veins like slow lightning. Beetles chew through the softer parts. Springtails, ants and mites follow. The leaf becomes food, shelter, fuel. But decomposition is more than digestion. It is also chemistry. Organic matter, carbon-rich material built by sunlight and time, is disassembled into smaller pieces. Amino acids, sugars, minerals, simple compounds. These fragments are absorbed by microbes and plants, carried into roots, woven into new life. Nitrogen is one of the most crucial elements in this cycle. Though it makes up most of our atmosphere, it's largely unavailable to plants in its gas form. So soil microbes convert it, through nitrogen fixation and ammonification, into a form plants can use. Without this conversion, the forest could not grow. Phosphorus, too, cycles through decay. Found in bones, seeds and cells, it is released when organisms decompose, absorbed by fungi and plant roots. Potassium, calcium, magnesium, all the essential nutrients are set free again through death. It is the most generous release in the natural world, the giving back of what was once held tight. The carbon cycle, too, spins through decomposition. As microbes and fungi break down organic matter, they release carbon dioxide through respiration. This CO2 rises back into the atmosphere, where it can be used again in photosynthesis. A fallen tree may store carbon for years, as it slowly rots, releasing it in whispers, not shouts. This slow return allows the forest to regulate its own breath, preventing sudden imbalance. But these cycles do not operate alone. They overlap, support, and mirror one another. One organism's waste becomes another's feast. A dead animal nourishes a patch of soil that grows a vine that feeds a monkey whose droppings scatter more seeds. Energy flows, but nutrients cycle endlessly, and decomposition isn't limited to the floor. Epiphytes high in the canopy create their own nutrient cycles in pockets of decaying leaf matter caught in their roots. Bromeliads collect fallen debris in their water-holding tanks, breaking it down with the help of aquatic insects and microbes. Even the air hosts decomposers, fungi that digest airborne pollen, bacteria that consume floating organic dust. This constant breakdown is not ugly. It is sacred. A rotting log becomes a nursery. A crumbling leaf becomes the ink of tomorrow's green. The forest understands what humans often resist, that endings are not failures, but fuel. You kneel and touch the edge of a decomposing branch. It flakes in your hand. Soft, dark, almost soil. You see it clearly now. This is not waste. This is wealth. What was once tree will be tree again. And as you breathe in the warm, earthy air, you realize that this smell, this mix of musk and sweetness, dampness and memory, is not death. It is return. Beneath the surface of the rainforest, unseen and often unthought of, lies a system as vital and intelligent as any heartbeat, the immune system of the soil. Just like your body defends itself from infection, the soil too must protect itself, not with white blood cells or fevers, but with microbial alliances, chemical warfare, and adaptive memory. In this complex underground world, survival depends on balance, vigilance, and response. You press your hand into the damp earth and feel its softness, its quiet warmth. What you cannot see are the billions of organisms within that handful, each one a participant in the defense of the system. Bacteria, fungi, protozoa, nematodes, and more, all play roles in keeping invaders at bay and in maintaining a thriving, functional community. These microbes aren't passive, they are watchful, strategic, alive with intent. The first line of defense is diversity. A rich and varied microbial community means that no single pathogen can dominate. In a diverse soil system, any new invader, a harmful fungus, a parasitic nematode, a bacterial disease, faces immediate resistance. Competitors crowd it out. Predators feed on it. Antimicrobial compounds flood the zone. Just like in the rainforest canopy, competition becomes stability. Many beneficial soil microbes produce natural antibiotics. Species of Streptomyces bacteria, for example, release substances that inhibit fungal infections. Some bacteria produce hydrogen cyanide to deter root pests. Others emit volatile gases that trigger nearby plant roots to strengthen their cell walls. These chemical signals are the soil's language of defense, spoken molecule by molecule, sent through air pockets and water films in the soil's microscopic architecture. Plants don't simply rely on the soil's defenses, they contribute to them. Through their roots, they exude compounds known as root exudates, sugars, amino acids, phenolics, and even defense-related proteins. These substances feed and attract beneficial microbes, while simultaneously repelling harmful ones. In effect, a tree cultivates its own guardians, feeding the microbial allies that protect it. This relationship is dynamic. If a plant is under attack, it changes its exudates to summon different microbes, sending chemical help messages deep into the soil. Some fungi form protective sheaths around roots, physically blocking pathogens from access. Others, like mycorrhizal fungi, outcompete harmful invaders for space and nutrients. Their networks don't just nourish, they guard, they patrol, they react to threats not with fear, but with precision. There are also protozoa and nematodes, often seen as neutral or harmful, but in balance they serve a regulatory role. They graze on bacteria and fungi, keeping populations in check. Like predators in the canopy, their presence prevents overgrowth, allowing healthy microbes to flourish while keeping pathogens at low levels. What's most remarkable is the soil's capacity to remember, not in words or conscious thought, but in microbial shifts. After a disease passes through, the community adjusts. Survivors remain. Defenses strengthen. A new generation of microbes grows more resistant. Scientists call this soil priming, the enhanced readiness of a soil ecosystem to defend itself after previous exposure to stress. The forest does not forget, it adapts, and this immunity extends beyond the soil. Above ground, the health of leaves, bark and fruit reflects the resilience of what lies beneath. A tree with a strong microbial community at its roots is more likely to resist blight, drought, even insect attack. Its leaves will produce more defensive compounds, its branches more resilient growth. The immune system of the soil becomes the immune system of the forest. You crouch near a rotting log, watching tiny mushrooms push up through the mulch. Fungi feeding, recycling, defending. The scent in the air is rich, not just with decay, but with resistance. The forest is not passive, it is actively alive, down to its smallest cell. And beneath you, below the layers of fallen leaf and silent root, the rainforest's immune system continues its quiet work, watching, adjusting, remembering, so that life above can flourish. Beneath the surface of the Amazon rainforest, a hidden web stretches out, not of vines or roots alone, but of fungal threads, fine as silk and vast as thought. These threads are called mycorrhizae, and they form one of nature's most intricate intelligent systems, a communication network that allows trees to talk, to trade, to warn, and to remember. It is not metaphor, it is not magic, it is science, quietly unfolding beneath your feet. The term mycorrhizae comes from the Greek words for fungus and root, and that is precisely what it is, a symbiotic partnership between certain fungi and the roots of most plants. The fungi weave themselves into the root tips of trees, forming either intimate internal networks, a buscular mycorrhizae, or sheathing the roots in a protective rhapectomy mycorrhizae. In both cases, the exchange is simple but profound. The tree provides sugars made from sunlight. The fungus provides water and nutrients, drawn from the soil's hidden corners. Together, they create more than survival. They create connection. But this network is not limited to one tree and one fungus. It spans entire forests. Through these fungal highways, trees connect to one another, sometimes across species. A seedling struggling in shade may receive extra carbon from a towering elder tree. A tree wounded by insects may send out chemical warnings, prompting others nearby to produce defensive compounds before the danger arrives. The forest does not just grow together, it thinks together. These exchanges happen in silence and darkness, yet they are sophisticated. Some trees invest more heavily in the network, sharing generously and receiving more in return. Others may cheat, taking but giving little. The fungi remember, over time the network shifts its attention, its generosity, its loyalty, relationships form. Not based on emotion, but on reciprocity and need. Scientists once called this system the Wood Wide Web, and while the name may sound whimsical, its complexity rivals anything humans have built. Nutrients, water, information, even electrical impulses pass through the fungal threads at measurable speeds. When one area of the forest is stressed, by drought, by attack, by disease, the response can ripple outward. Other trees adjust their behavior. Fungi shift their resources. It is not a central brain, it is a distributed intelligence. Not every plant participates. Some, like certain orchids, rely entirely on the fungal network during germination, using it to steal nutrients until they can photosynthesize. Others tap into the system without contributing, siphoning energy, while offering nothing in return. And still the network endures, balancing generosity and resistance, welcoming new roots, discarding the unhelpful. You crouch beside a cluster of saplings, their trunks thin but rising steadily. They are not alone. Though their roots barely reach, the mycorrhizae stretch beneath them, linking them to older trees, to the soil's wisdom, to the memory of rain and drought. Without this network, they would not survive the shadows. The light may be distant, but help flows invisibly below. Sometimes when conditions are just right, warm, wet, rich with decay. The fungi send up fruiting bodies, what we call mushrooms. These are only the briefest glimpses of the vast underground web. Like flowers blooming from roots that think, they remind us that the forest's greatest architecture is often unseen. And now, as you rise and brush soil from your hands, you realize you've been walking atop a network that speaks in silence, that learns and remembers, that nourishes both the strong and the small. A conversation has been happening all around you, not in words but in molecules and threads. This is not just soil, this is intelligence made of roots and rain. Fungi are not plants, they are not animals, they are not passive, nor simple, nor slow. In the shadowy, humid heart of the Amazon rainforest, fungi are thinkers, not with brains or nerves, but with branching logic and responsive growth. They sense, they decide, they adapt. And in the quiet places beneath the roots and within the logs, they solve problems as fluidly as any creature with eyes and legs. This is fungal intelligence, ancient and essential, and it thrives in a realm where most life is blind. You crouch beside a fallen tree, its bark softening into sponge. A thin web of white threads glows faintly just under the surface, mycelium, the body of the fungus. These threads stretch outward in every direction, splitting, pausing, rejoining. They are not random, they explore with purpose. When one thread meets rich food, a pocket of nutrients, a decaying seed, it pulses, strengthening and growing. Other threads follow, building a network not unlike a brain's synapses. And when the path leads to stone, or poison, or competition, the threads withdraw, redirect. Decision is made not with thought, but with movement. This growth is not chaotic, it is exquisitely efficient. In laboratory studies, certain fungi have been shown to find the shortest route through a maze, to optimize resource distribution, even to mimic human-designed networks like Tokyo's subway system. And yet these decisions are made without eyes, without ears, without central command. It is intelligence emergent from connection, the same principle behind flocks, swarms, ecosystems, even memory. In the rainforest, this intelligence expresses itself through timing. Some fungi remain dormant for months or years, waiting for the right conditions, the right level of moisture, warmth, decay. Others change form entirely depending on their environment. A fungus that lives peacefully inside a tree's tissue, as an endophyte may, under stress, switch roles and become a decomposer, breaking down the same tree it once protected. Adaptation here is not hypothetical, it is constant. Fungi also negotiate. In relationships with plants, they manage a careful economy of sugar and nutrients. If a plant provides more carbon, the fungus offers more phosphorus. If the trade becomes unbalanced, the exchange slows or stops. Some fungi play favorites, delivering more resources to host trees that are genetically related to them, or that feed them more generously. In this way, fungal networks shape forest growth not just randomly, but selectively, favoring certain partnerships over others. And fungi remember, not in the way animals remember, but through change. A fungal network that has encountered drought may grow differently the next time water is scarce. Its branching patterns shift, its chemical signals adjust. It learns through experience, storing information in the shape of itself. The rainforest rewards this kind of intelligence. Competition for space, nutrients and decay is fierce. Dozens of fungal species may colonize a single log, competing chemically and spatially. Some secrete enzymes that melt through wood faster than others. Some produce antimicrobial compounds to keep bacteria away. Others build fortresses of hyphae that lock out rivals. And yet many also collaborate, forming microbial guilds where different fungi specialize in different stages of decomposition. Together they turn wood into soil faster than they could alone. Then there are the fungi that partner with animals. Leafcutter ants, for instance, cultivate fungal gardens in their nests, feeding them chewed leaves and harvesting their swollen hyphal tips as food. The ants protect the fungus from invaders. The fungus feeds the colony, Over generations both have shaped each other, and agriculture older than human civilization evolved in the damp dark chambers beneath the rainforest, and when the time comes to reproduce, the fungus speaks again, not in sound but in spores. Some launch into the air with explosive force, others ride the wind, the rain, the fur of animals. A few wait inside fruiting bodies that glow softly in the night, bioluminescent invitations to insects who will carry their message farther. Even here in reproduction, fungi show strategy, creativity, and patience. You lean close to a rotting root, and notice the faint outline of a fungal fruiting body just beginning to emerge. It's soft, wet, and almost invisible, but within it lies a system that spans meters, perhaps more, adjusting itself with every signal it receives. It has no eyes, no ears, no tongue, and yet it knows exactly where it is. In the Amazon, death is not an end, it is an opening, a transition, a quiet doorway into rebirth. Every fallen branch, every rotting log, every insect husk and broken seed, each one becomes a seedbed for the next generation, and standing at the very center of this transformation is the kingdom of fungi. These organisms do not fear death, they feast on it, shape it and return it, gently, patiently, into life. You walk along a forest trail, where the air is thick with the scent of wet earth and rot. To some this might seem unpleasant, but here in the rainforest, that smell is a signature of renewal. It is the breath of decomposition, the scent of work in progress. Beneath your boots, a layer of fallen material is slowly softening, changing, not vanishing, but reorganizing. The dead are not buried here, they are absorbed. Fungi begin the process even before the eye can see change. A fallen leaf, still fresh and green, becomes host to spores drifting invisibly through the air. These spores germinate and send out hyphae, thread-like structures that weave into the leaf cells, releasing enzymes that digest its tissues. Slowly the leaf softens, darkens, curls. Its structure collapses not from time alone, but from attention, the intimate labor of fungi dismantling its body and releasing its nutrients back into the soil. Larger bodies, branches, trunks, animals, take longer, but the work is the same. Inside a fallen tree, different fungal species colonize different zones. Some break down lignin, the dense compound that makes wood hard. Others specialize in cellulose, or extract rare minerals. Still others create antibiotics to keep competitors out. This is not just feeding. It is negotiation, defense and cooperation, all in one silent process. As the wood darkens and crumbles, new life forms begin to appear. Mosses, seedlings, beetles, amphibians. A decaying log becomes a city, vibrant and temporary. Fungi are not picky, they will take whatever the forest offers, from fruit to feathers, from dung to dead bark. Their flexibility allows them to respond instantly to change. When a storm brings down a tree, spores lying dormant in the soil may awaken, ready to begin their work. Others may arrive by wind, by water, or in the guts of insects that crawl into the moist shelter of decay. But decay is not destruction, it is a return. The nutrients released by fungi, nitrogen, phosphorus, carbon, are not wasted. They are gathered by roots, drawn into sap, used to build new cells. A tree grows tall by feeding on the bodies of the trees that came before. A flower opens, fed by the leaf it once shaded. Death is folded into the shape of living things, carried forward invisibly. The rainforest is built not just on survival, but on acceptance, the deep structural acceptance of impermanence. And some fungi carry this truth even further. The genus Cordyceps, for instance, infects insects like ants or caterpillars, growing within their bodies, until it takes over their behavior. The infected insect climbs high, locks itself into place, and dies. Then a fruiting body emerges from its corpse, releasing spores to fall on the forest floor below. It seems brutal, and it is. But even this is part of the cycle, a way of recycling not just tissue, but space and energy. The forest does not moralize, it transforms. You stop before a massive rotting trunk, hollowed and soft. Within it a young seedling rises, delicate green, impossibly alive. Its roots push through the softened wood, tapping nutrients that once formed another tree's core. This sapling does not know the name of the one that came before, but it carries its essence, not in memory, but in matter. The fungi below do not weep. They do not cling. They simply continue, breaking down, redistributing, preparing. They are the alchemists of the rainforest, turning death not into loss, but into foundation. And as you step forward, you realize you too are part of this. Your breath feeds plants. Your cells carry recycled atoms. Even your footprints press briefly into soil that once held the bodies of stars, of trees, of time itself. Here in the rainforest, nothing truly ends. As the sun dips below the canopy, and the final ribbons of gold slip away, the rainforest enters a different state of being, one shaped not by light, but by perception beyond sight. For many of its creatures, darkness is not a barrier. It is home. In the thick velvet blackness of night, where even moonlight struggles to reach the forest floor, animals continue to hunt, to feed, to mate, guided not by color or clarity, but by warmth, movement, sound, and scent. They do not see the way we see. They see without light. You sit in silence, letting your eyes adjust, but no matter how long you wait, the world does not reveal itself fully. The shapes remain shadows, the edges blur, and yet around you life flows without pause. Frogs leap, bats wheel, owls fix their gaze on branches you cannot even distinguish. There is sight happening here, just not the kind tied to brightness. Many of these creatures rely on infrared vision, a sensitivity not to reflected light, but to radiated heat. Snakes, such as the Amazonian pit viper, possess special organs near their noses, heat-sensing pits lined with membranes that detect thermal radiation. These structures can see the warmth of a mouse or bird in total darkness, outlining prey like glowing embers in the void. A flick of the tongue samples chemical trails. A slight tilt of the head narrows the target. The snake strikes, not blindly, but with precision shaped by temperature. Bats, meanwhile, navigate and hunt with echolocation. They emit high-frequency calls, too sharp for human ears, and analyze the echoes that return from their surroundings. These echoes paint a three-dimensional map of the world, each branch, insect, and leaf sketched in sound. With this sonic blueprint, a bat can catch a mosquito mid-flight, avoid trees, and return to its roost without ever relying on light. Their ears are their eyes, honed by evolution to detect detail finer than even radar. Nocturnal insects, too, are masters of darkness. Moths possess supersensitive compound eyes that can detect even a single photon. Their large lenses and wide pupils allow them to gather ambient light, but it's their neural processing that truly astounds. Some species combine weak visual signals over time, building a more stable picture of their surroundings by integrating flickers into clarity. It's like painting the forest, pixel by pixel, out of dimness. Many mammals of the night enhance their sight through tapetum lucidum, a reflective layer behind the retina that bounces light back through the photoreceptor cells, effectively giving them a second chance to detect each photon. This is what causes the glowing eyes you sometimes see in flashlight beams. It's not magic, it's adaptation. Others abandon sight altogether. Moles, some amphibians, and deep soil burrowers rely on touch, vibration, and chemical cues. Their skin can detect changes in air pressure, their noses track pheromones, antennae twitch toward wind or warmth. In their world, to see is to feel, to taste, to listen, senses tuned not to color, but to context. In the Amazon, bioluminescence is also a tool of nighttime sight, but in reverse. Some insects, fungi, and even fish emit their own light. Click beetles pulse with soft yellow under their thoraxes. Certain fungi glow green at the base of rotting logs, lighting the path for nighttime foragers, or attracting insects to spread spores. In deep forest streams, flashlight fish signal with photophores under their eyes. These lights are not just for others, they are for themselves to understand space, partner, threat. You remain still and open your other senses. A breeze carries the sweet metallic scent of sap. The chirp of frogs shifts slightly in pitch. Something rustles in the undergrowth. You can't see it, but it's there. The forest is not asleep. It is watching, just not with human eyes. Animals here do not fear the dark. They are shaped by it. Their evolution is not defined by what is illuminated, but by what glows, echoes, radiates, or rustles. In doing so, they reveal something profound, that vision is not bound to light. It is bound to need. And here in the ink-black warmth of the jungle night, need becomes perception. The rainforest never truly goes silent. Even in its deepest hours, when moonlight fades into mist and the canopy rests like a giant sleeping lung, the forest speaks. Not in words, but in pulses, in tremors, in ripples of vibration and sound that pass through air, leaf, water, and bark. In the dark, where sight dissolves, sound becomes a way of seeing, a language used by frogs, bats, insects, birds, and even the trees themselves. Every whisper has a meaning. Every vibration is a message. You close your eyes and listen. A high-pitched whine spirals upward from somewhere near your ear, the sonar pulse of a bat slicing through night air. Moments later, a soft plop as something drops into a puddle. A low rhythmic croak echoes from the underbrush. Farther off, something sharp, like a snapping twig, repeated in rhythm. The voice of a katydid marking territory. These sounds do not compete. They layer, each species selecting its own frequency range so it can be heard in the chorus. Scientists call this the acoustic niche, a kind of sonic real estate that allows thousands of animals to communicate at once, without drowning each other out. For many creatures here, sound is not just expression, it's navigation, defense, and intimacy. Frogs, especially during the rainy season, form great sonic tapestries that stretch for miles. Each male sings not only to attract a mate, but to define a pocket of territory, to warn rivals. The calls are specific. A slight change in rhythm or pitch signals whether the frog is threatened, excited, or injured. The females know these subtle differences. They have evolved to understand them, because survival depends on it. Insects, too, communicate through vibration as much as sound. Leafhoppers tap their feet against stems, sending tremors that travel invisibly through plant tissue. These signals reach potential mates, without ever making a noise detectable to predators. Some caterpillars produce warning vibrations by drumming their bodies on leaves, announcing their presence to competitors. Even spiders can hear through web vibrations, deciphering the weight and movement of trapped prey from a single thread's shiver. Bats, as you've already sensed, operate on a level far beyond what human hearing can perceive. Their echolocation calls are bursts of ultrasonic sound that bounce off objects and return as precise data, distance, shape, movement, even texture. One species, the greater bulldog bat, uses echolocation to detect ripples on the surface of rivers and pluck fish out of the water in total darkness. Their ears are not just for listening, they are instruments of vision, but not all sound here is animal. The forest itself participates. Branches creak, trunks shift, and roots groan softly beneath the weight of moisture and decay. During rainstorms, large trees can resonate like giant wooden drums, vibrating with the force of falling water, and when a tree falls, the entire forest knows. Birds call in alarm, monkeys scream, insects go quiet. The sound carries more than impact, it carries change. Some researchers now believe that trees may even communicate using ultrasonic clicks through their xylem, tiny sounds emitted as water moves through capillaries in their trunks. These vibrations might signal drought stress or coordinate growth patterns. It's still being studied, but the implication is clear. The forest does not just echo sound, it makes it, and perhaps it listens too. And within this web of vibrations and echoes, every creature must learn to read its world through sound. A jaguar, moving silently through the dark, slows when the frogs stop singing. A sudden silence means a predator is near. A shifting rhythm in the night chorus hints that rain is coming. The absence of sound becomes a sound itself. You place your hand on the trunk of a large tree. It is not speaking aloud, yet something within it stirs, sap flowing, bark shifting, roots sensing. Even here, in the stillness, there is motion, there is meaning. The language of the forest may not be heard in the usual way, but it is all around. In this place, sound is not just communication, it is connection, awareness, and memory. To live in the rainforest is to listen with your whole body, to hear with your feet, your skin, your breath. And in doing so you become part of the story, being whispered between the leaves. As daylight retreats and the forest slips into shadow, a second life awakens, quiet at first, like a breath held between heartbeats. Then slowly, the rainforest pulses back to life, but this time it moves with a different rhythm, the rhythm of the nocturnal. By day the Amazon glows with color and noise, with birdsong and sunlight, but by night it whispers, creeps, hums and breathes in a deeper way, like it's dreaming with its eyes open. You sit beneath a wide canopy, the last glow of the sun dissolving into violet mist. Around you the light grows dim, and the sounds begin to shift. The sharp chatter of diurnal birds gives way to the soft rustle of wings, the echoing trill of night frogs, and the droning of countless insects. From high above the flutter of a bat sounds like rain. From below the padding of paws in leaf litter, a feline, maybe, or a tapir, is barely audible. The forest becomes a theater of senses not built for human eyes, but for those adapted to feel more than see. Some creatures, like the nocturnal monkeys, owl monkeys, or night monkeys, awaken now, with large light-gathering eyes and sharp hearing. They leap quietly from branch to branch, foraging in the darkness. Their world is painted in shades of grey, but rich with movement and scent. Their calls are low and mournful, like echoes left behind by dreams. On the ground, the ocelot prowls, a ghost cat with spotted fur made for moonlight. It hunts alone, stepping without sound, its ears turning like radar dishes to locate the soft scratch of prey. It is not rushed. Night stretches long, and in its slowness, the ocelot becomes the forest's breath, drawn low and quiet. Not far away, armadillos and anteaters emerge from burrows, their long snouts twitching for the trace of ants and termites, hidden beneath bark and soil. Among the branches, kinkajous, honey bears, move like liquid shadows. Their tails grip, their paws reach, their noses dip into flowers, sipping nectar like floating bees in furred disguise. Their movement seems playful, but every step is deliberate, every leap informed by 1,000 hours of climbing in the dark. They see not with detail, but with memory and instinct. Even the insects change. Fireflies blink in slow patterns, signaling love through code. Giant moths, wings broad and silent, flutter toward unseen blossoms, guided by fragrance, carried on the night wind. Some, like the sphinx moth, hover like hummingbirds, long tongues unrolling to drink from flowers, evolved specifically for their midnight visits. Amphibians take center stage too. Tree frogs, glowing faintly green under the moon, cling to leaves slick with dew. Some inflate their throats, like balloons, and call into the night. Croaks, chirps, whistles, each species with its own rhythm. Their voices rise like music from still ponds and dripping bromeliads, forming a harmony only possible in the absence of daylight. And in the undergrowth, the invisible engineers continue their work. Leafcutter ants, whose trails by day stretch in clean lines across the forest floor, march in narrower columns now, their load still heavy. By the light of bioluminescent fungi or starlit gaps, they continue building, tireless, purposeful. In this nocturnal world, there is no pause, only shift. Above all, the trees themselves do not sleep. Their stomata open wider in the coolness, breathing more freely. Their roots drink in moisture, their leaves adjust to catch dew. The forest is not dormant, it is dreaming aloud, its processes slowed but never stopped. And as you lie back, letting your body settle into the hush, something inside you mirrors this rhythm. You become part of the darkness, not lost in it, but embraced. You feel the forest around you not as scenery, but as presence. You are no longer an observer, you are part of the nighttime breath. And just before your eyes close completely, you notice the night doesn't need light to be alive. It just needs stillness.